Okay, so now we're talking about simplifying radicals. This time we're going to consider the case of simplifying radicals with variables. So begin with the problem, what if we had square root of x squared? What thing would we multiply times itself to get x squared? Now most people initially jump to the idea that it's x. But are we really sure that square root of x squared is x? We might want to do a little bit of testing first. So let's consider a couple of numbers. What if I did square root of 2 squared? Well, 2 squared would be 4. The square root of 4 would be equal to 2. So that works no problem. So it seems like the idea is square root of x squared being x kind of makes sense. But hold on. Consider the square root of negative 3 squared. Negative 3 squared is 9, and the square root of 9 is 3, so when we apply it to negative 3, we're actually getting 3, not negative 3. And so this doesn't quite work. So for positive numbers, it gives us exactly what we want. But for negative numbers, the sign's going away. And so think back to yourself for a moment. What operation have you used that when you apply it to a positive number, it gives you that number, but when you apply it to a negative number, you get the positive value? And the answer is absolute value. So square root of x squared is actually absolute value. But we kind of say to ourselves, oh, yuck, that's kind of ugly. And we give it a little yuck face. You may remember it as a kid dealing with the little green stickers, stuff you shouldn't drink. Yuck. That doesn't look nice. So what we're going to do, and what's typically done with these kind of problems, is we make an assumption to make our work easier. And the assumption is that we're going to assume that all the variables take on positive values. That way, we can say that square root of x squared is equal to x. Now, we do that assumption to make things easier, but realize that if x can be positive or negative, the square root of x squared really is absolute value. And that's going to become important in the next chapter, in the next unit. But for now, we're going to make the assumption that all of our variables right now in these kind of problems where we're simplifying radicals, all of our variables are positive, and that makes life a little easier on us. So with that in mind now, let's consider square root of x to the fourth. What thing would you multiply times itself to get x to the fourth? And the answer is pretty simple. It's x squared. Because properties of exponents, x squared times x squared, 2 plus 2 is 4. What about x to the sixth or x to the eighth? I'd ask you to pause the video and think about that. So what would you multiply times itself to get x to the sixth? Well, that would be an x to the third. And for x to the eighth, what would you multiply times itself? Well, x to the fourth. 4 plus 4 gives me 8. Okay, sorry, I got interrupted there with someone stopping by. So anyway, we are looking at these problems here. X to the sixth, square root of that is x cubed. Square root of x to the eighth is x to the fourth. You might start seeing a pattern here, so let's throw another one out here and maybe think about that for a moment. What would you multiply times itself to get x to the 20th? And the answer is, well, I'd do x to the 10th, because 10 plus 10 is 20. And so you quickly start to see here that when I'm doing this square root, what I'm really doing is I'm taking that exponent and dividing it by 2 in every case. And so this will work real well if we have an even number. But then the question comes to mind, well, what if we have a square root of something to an odd exponent? And we want to take a look at those. Recall with numbers, we used this result that said when we have a square root of a product, we can break it up and take the square root of each piece to simplify. And so if we had, for example, x to the third, 2 doesn't go into 3 evenly. But what I can do is say, well, x cubed can be rewritten as x squared times x. And so I could write it as square root of x squared times square root of x. And then we can do the square root of x squared. Alright, that's just x. And then square root of x, that thing's just stuck inside there because 2 won't go into 1, which is the exponent on the x. So we get x square root of x. In our next example, consider x to the 11th. Well, we could write that as x squared times x to the 9th, but wait a minute. That seems like too much work, because then we got to break up the x to the 9th. So if we're going to rewrite it, we should rewrite it using the biggest possible power we can get that 2 would go into. So in the case of x to the 11th, that would be x to the 10th. And then we can take 2 into 10 and get x to the 5th. And so the answer would be x to the 5th times the square root of x. Okay, we have one more example. This time is a square root which has a bunch of stuff in it. Well, to handle this, I would take and work with the square root of each piece. So now we're back to dealing with the number 24. Square root of 24. Remember, for a number, we rewrite that as a square. So 4 times 6. And we do the square root of 4 is 2. The square root of 6 we can't do anything about. Okay. Square root of x to the 8th we can do very easily. 8 is even, so 2 would go right into it. We get x to the 4th. And then we have square root of y to the 13th. 2 won't go into 13 evenly, but we can rewrite that as a y to the 12th times y. And then 2 will go into 12 6 times. And we have a square root of y left over. And then at this point, it's just a matter of putting everything together. So we take everything that was outside the radical, and we write that down, okay, together. And then we take everything that's inside the radical, the 6 and the y, and put those down together to get our answer. Okay, so we'll continue with some more examples of simplifying square roots with variables. Particularly, we're going to be looking at higher roots like cube roots and so on, and so we'll move on to those in the next video.